Okay guys, so our project is on derivative, so we're going to be teaching you guys about derivative, and this is presented to you guys by Ana Salinas and me, Alondra Gonzalez. So say hi, Ana.
Hi.
Okay, so I'm going to be teaching you guys about the power rule. This is Alondra. So yeah, the power rule is basically one of the ways that we can find a derivative. Alright, so n, this is going to be our equation right here. And n is going to be any known number, any number that you already know, right? For example, let's use 6. So let's put x to the 6th power. So this is going to jump right off, right here, and then you're going to do -1, minus that number. So the derivative of x to the 6 would be 6x to the 5. So do you see how like the 6 jumped off and then the -1, which made it a 5? So that's basically like the easiest way of getting a derivative, and that's the problem.
So you all should know already about limits and continuity. So have you known that you guys a derivative exists only when a function is continuous, which means when the limit exists, like limit to the left equals the limit to the right, and when the limit itself equals the point of the graph, and when the slope from the left equals the slope from the right. We should probably make an example of that because I don't think I'm being very specific about that. So let's pick a piecewise function, 2x plus 3 when x is less than 1, and x squared plus 2x plus 2 when 1 is less than x, which is less than 5. Okay. So right away you guys should see that this is from the left and this is from the right. The right side of the function. Okay, first we need to know if it's continuous. Okay, so we need to know if the limit from the left equals the limit from the right. So let's find the limit from the left first, which we know we're gonna pick this function since this is from the left. Okay, so limit as x approaches to 1 from the left. Notice that I put the sign there from the left of the function 2x plus 3, and we just plug in 1, so 2 times 1 plus 3, which is 5. This is the limit from the left. So now let's find the limit from the right. So limit as x approaches 1 from the right of the function, and now we're gonna use this one since this is the right side of the function. X squared plus 2x plus 2, and we'll just plug in 1. 1 squared plus 2 times 1 plus 2, which equals 5. So since these two are the same, the limit from, well, the limit itself overall as x approaches 1 equals 5. Now let's see if it's continuous. So f of 1, we're gonna plug 1 into the into this equation right here. Now we see that the point itself is equal to 5, so the function is continuous at 1, at x equals 1. Okay, now let's check the slopes, which is the final step of the to know if the derivative exists. Okay, so the second step is about slopes. Let's check the slope from the left and the slope from the right. Okay, So from the left, can you still see this? You can? Look up. This? Okay. So we're still gonna pick the function that we had from the left. So it's 2x plus 3. And we're gonna take the slope of that. And we're gonna take the slope of this function. And we're gonna check if these two slopes equal the slope from the left and the slope from the right. In here the slope will be 2, and later on Alondra's gonna explain why. I just want you guys to know what a derivative is, like when it exists. So, but later on she's gonna explain about taking the derivative of a function. And right here is 2x plus 2, which then equals 4, since x equals 1, right? From the functions above. So then we see that the slope from the left is 2 and the slope from the right is 4. So therefore, the slopes do not equal each other. Therefore, there is no derivative at x equals 1, even though the function is continuous.
Okay, so hey guys, I'm going to show you guys the product rule. So basically the product rule is a different way to finding a derivative, and it's when you have a product. Like let's say you have two functions and you have to multiply them, right? And usually you'll see them like this, you know, with the parentheses, which means to multiply, right? And to be able to find the derivative out of like a multiplication where you would have to do, you know, a FOIL and all that stuff, it's a lot of work. It's too messy. So here's the thing that we people do in calculus, okay? What we do is that first I'm going to take this function and I'm going to call it equation f of x, that equation, and this equation I'm going to call g of x, okay? And for f of x, I'm going to take the derivative, okay? So f of the function is 3x, the equation, and the derivative, you guys remember the power rule, is just going to be 3, okay? And I'm going to do the same thing for g of x, right? So let's get the derivative, 8x. First that's the equation, and let's get the derivative. So the derivative is 3 minus 1 would be x squared, and whenever you have something like this, you're going to multiply. When this bounces off, you're going to multiply it with whatever's already under. So 3 times 8 would be
24.
24. Very good, Anna. Such a good student. Alright, so 24x squared plus, and then we only have 6, so it's going to be 6. Right? So here's what we're going to do. Instead of having like something really messy, we're going to do our equation to finding the derivative is going to be to take the first equation, so it's going to be 3x times the derivative of the second equation, which we have right here, 24x squared plus 6, okay, plus the equation of the second times the derivative of the first, which is just 3. And then you just, you know, do all your multiplication, you simplify, and there is your derivative. And that was a product rule. Okay, so I'm going to teach you guys about the quotient rule now. The quotient rule, you know, as we can see right here, root word being quotient. And as you guys know, quotient is part of a division. So the quotient rule is going to be about two functions being divided and how to get the derivative of them, right? So let me give you guys an example. So here we have y equals x plus 3 over x plus 6, right? And they're being divided, you know, and it's another one of those things that it's going to get really messy, so that's why we have one of these rules, right? So basically what we're going to do is we're going to call this one on top fx and this one on the bottom g of x, right? The equations. And we're going to do the same thing as in the product rule, where we're going to get the equations and get their derivatives beforehand. So the derivative of this would just be x and g of x, which because it's only x, it's 1. Okay, and this one, the same thing. You know that adding doesn't really matter. So it would also be dy dx, which is another way of saying derivative, is 1. So both derivatives are 1. So that's going to be an easy one. Okay, so this is kind of how the quotient rule goes. We're going to call this high and this one low. Okay, kind of like that. So we're going to go low, which is g of x. We're going to get that equation, the equation of low, and d high. You know how sometimes you write the derivative like that? Okay, so it's going to be the derivative of the equation on the top, right, that we call high, and which is just 1 minus high, which is the equation on top, d low, which is the derivative of the equation that's low, which is also 1, over low squared. So you're going to get the whole equation of low and square it. And then you do, okay, so x plus 6 times 1 is x plus 6 minus times 1. But then you multiply this, so it's going to be negative x minus 3 over x plus 6 squared. And you also distribute and simplify, and you would get your derivative, and that's the quotient rule.
Okay guys, I'm gonna be teaching you the chain rule now.
Ooh, scary.
Yeah, they can get a little scary sometimes. But right now we're just gonna do a simple one, which if you notice, you have a trig function here, and I'm gonna show you guys the derivatives of the trig functions, which is just this. We're gonna use tangent, so you can see right here that the derivative of tangent is secant squared x. So having that known, let's start. Okay, so first of all, we're gonna identify the chain, which is 3x because it's inside the parentheses, and we're gonna call it u. So u equals 3x, and we're gonna rewrite the function, which is tangent of u. Okay, so now we're gonna write the derivative equation, which is the derivative of this times the derivative of u. So we know that the derivative of tangent x is secant squared x. Sorry. Okay, so then the derivative will be secant squared times u times the derivative of u. And right here we have u, and the derivative of u, since Alondra taught you guys the power rule and all that stuff, we know that the derivative is 3. Okay, so now you just plug in all your u's in the derivative of u. So the answer will be secant squared of 3x times 3. And you rewrite this 3 secant squared of 3x. And that's it. I hope that's helpful.
Chain, 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 chain. Chain, chain, chain.
Chain, chain, chain.
Remember your chains, children.
Remember the chains.
Holla.
Bye.
Okay, so just in case you guys actually worked it out, here are the answers that you were supposed to get to the product rule. You can see how we like distributed all of that, and actually got this as a derivative since we like factored from this, we factored it out, and that should be your answer. And now let's see your answer to the quotient rule. So as you can see here, you know, x minus x, they come out, you get 6 minus 3, you just move this over, and you ultimately get as your derivative 3 over x plus 6 squared. And as you can see here, it is your derivative. And that's it. Thank you. Okay, so here we are going to show you guys a real life example of derivatives. Okay, so first your position would be kind of like your function, and then the velocity at which you're moving and going at will be your first derivative. Okay, so when you accelerate and decelerate, you are using your second derivative. Whoa! And that was derivatives. The end.
I hope that's helpful. Thank you.